Next up, we're going to try to produce maps of countries in the world, right? Sometimes these maps are also called Choropleth maps or simple heap maps, right? Let's take a look at a couple examples here on my favorite rgraphgallery.com website, where they produce some interesting examples, right? So these are all examples of Choropleth maps or basically country maps. The basic concept is you already have a predefined area, the borders of countries, and you want to put something on top of it or color them differently, and so forth. So the map that we're going to produce now is going to look something like that, almost as pretty as the ones online, right? So this is a map of Europe, and we're going to use our students' data set, and we're going to color the countries differently depending on where most of our students studying at the university come from, where they were born, right? Let's go to R and start producing this country map. First, you got to load two packages that are crucial here, the maps package and the Viridis package. So use the library function, load them both, make sure you have installed them first using the install.packages function. Now, this works differently than what we've done before with the ggmap function or the qmplot function. With the ggmap function, we basically gave our either coordinates or a name of a place, and then our downloaded the map for that particular place or these coordinates, and then we plotted something on this particular map. This is great if we want to map specific locations, maybe in really small scale areas and locations, so forth, right? Now for the country level map, we're going to use a slightly different approach. We're going to first get a data set into R that has the coordinates of all the countries in the world and actually all the sub-regions as well. So the guys from the maps package put this together and to allow researchers to use this data to actually just map countries and sub-regions and so forth. So the function that lets us import this data set of coordinates into R is called map_data. So if we just put map_data and then in parentheses world in quotation mark, and we're gonna save that data into the new data frame called world, we see here we have a new object popping up with actually a lot of observations, 99,000 rows observations and 6 variables. If we have a quick look at the world's data set, you're going to see how Polygon data looks like and how it is organized. This is crucial for you to understand how then later plot countries onto a map, right? So we have longitude and latitude coordinates. We have a group, order, a region, and a subregion. The region indicates a country. Let's say here we have Afghanistan. And if the subregion is empty, it means we're just talking about Afghanistan as a country rather than different subregions within Afghanistan, right? We have a order variable, which indicates the order of each GPS plot. And we have a group variable. So we tell R all of these GPS points somewhere in the world belong to the same group. The group in this case here is Aruba, for example, and we want these points to be connected with a line in the following order. And this is the order category here. Right, and if you remember in the very first video for week 8 here on maps, I introduced this concept of polygons, right? So this is polygon data, basically dots on a map connected by a line that together make up a country. Okay, so if we go back to R, we now have our world's data set here with all the countries in the world. Actually, for our map, we do not want all the countries in the world, right? We actually just want a map of EU countries. So how do we filter this data set? Well, we can define a new list object here and indicate just the names of all the countries that we want included in our map. And this is done through a vector, right? C, and in parentheses, a list of all the names and quotation marks of countries, and we save that in the object EU. Right? Then we're gonna call the same map data function again, but within it, we're gonna limit the region to actually EU countries. Right? We see we have now a Europe data set with a lot less observations here, just fewer countries. altogether, and they're limited to the countries that are specified here in EU. We're going to further restrict this data set by only leaving country level polygons in there, not for the subregions, right? So we're going to kick those out. What we're left with is this data set of roughly 6,000 coordinates for various EU countries. Okay, so now we can go ahead and actually plot that. We're going to use ggplot in combination with geom polygon. So we use the ggplot function that you're now very familiar with. We're going to indicate the data set that we'll use. And then we give the aesthetics, as always, with the x and y axes, in this case the longitude and the latitude variables from the Europe data set. And we're going to indicate a group argument here. And by the group, we specify the group variable to tell R that whoever has the same number here under group actually belongs to the same country, right? So the coordinates together make up the borders of one country. Okay. And then we're gonna tell R to plot polygons, the shapes, dots connected by lines, onto this frame. And we want countries to be filled with the color of light gray, and we want the lines to be white. The lines in this case are borders between countries, right? So let's see what that looks like. Okay, here we already have our map of some countries in the EU. The borders are white and the filling is gray. But now we want to actually use this map for our analytical purposes, right? We want to communicate a message. In our case, we have our students data set, and we want to show where students that are studying at this university in our data set are actually from, where were they born, right? And we want to indicate, we want to vary the color of each country by the number of students at the university, and we also want to input the actual number of students studying at the university within the within each country on the map. So to do that, we first got to merge some new data from our own data set of the students into our Europe data set to then visualize them jointly. Let's go ahead and do that. We're going to create a data set origin, which is based on our students data set. We group by the variable country of birth, and then we create just a new variable called students that summarizes the number of rows by every country of birth. As a reminder, let's take a quick look here at the students data set. We have our 1,000 students, and they all were born in different places. COB is country of birth. And we're grouping by this variable and just counting how many students are fall into each country of birth, right? Let's run that. Check out the origin data set. We have 7 different countries of birth, actually, and just one with missing information. For 9 students, we don't know where they were born. Now we're going to merge this data with our Europe data. This as well, if you go back to previous weeks, we've learned how to do this, merging data. We're going to merge here the origin data frame that we just created with the Europe data frame that we created up here using the map data command. And we're going to merge this by the country of birth variable in the X data frame, which refers to the origin, and the region variable in the Y data frame in Europe. Remember that we always need some sort of identifying ID to be able to link two data sets. In this case, they don't have the same name, but they contain the same information. So we can indicate this by using by X and by Y to tell R that we want to merge on those two variables. Okay? And we want to keep all rows and all observations, even in cases when we are not able to merge them together. So let's do that. We would call this new data frame student origin. And in this student origin data frame, right, here we are. Here's the country of birth information, number of students, and here are all the coordinates from the Europe data frame. Now we're going to indicate a new variable. We're going to create a new variable using mutate function in combination with case when function. Go back to previous week to check out how we did that. And this variable will just indicate whether we have information on the country of birth of students or whether we do not have any students from particular countries, right? Let's go ahead and create that. And now we're going to again use the ggplot function based on our new data set. The polygon data of countries combined with our information on how many students are from which country, right? And we're going to again indicate the longitude and latitude coordinates on the x and y axis, group them together. And now in the geom_polygon function, we're going to also list the grouping, and we're going to fill the countries depending on whether we have any students that were born in that country or not, right? This is the variable that we created just in the previous step. Let's run that, see what it looks like. Okay, now we can actually see, well, at in our university data, we do have some students that were born in Italy and France and Spain. For example, we have none that were born in Switzerland, for example, or I believe this is Belgium. Okay, this is already kind of informative, but we want to push it a little further. We want to actually show how many students come from each country and let the color vary depending on that. And we also want to put the actual number into the map. So let's continue. We want to plot color by how many students come from each country. And we just do this by actually adding here the argument fill equals students. Right? So rather than having just the availability indicator, now we have the color that indicates how many students. And we immediately see that apparently at our university, there are more students from Spain and Italy compared to, for example, to the UK. So far, so good. So now let's try to add the actual number of students, right? We do have this information in the student origin data set, and we created this variable here, students, which indicates how many students we have in each. Now we actually want to plot the specific number of students in each country, right? To label the country with how many students were born in that country. So this actually requires sort of a workaround and an additional step. We're going to create another data set called student origin 1, and we're going to group by the country of birth, the group, so which is identifying the country polygon, and the number of students, and we're going to actually take the mean of the longitude and the latitude coordinates, right? We're doing this because we need to tell R where to put the number on the map, because if it has too many coordinates, it doesn't know where to put the number, and it's going to put them everywhere where R sees GPS coordinates. So we have to give R one coordinate where we're going to place the number within the map. And to do this, we're creating the mean. And the mean, basically, what it does is create a centroid, basically the center point within each polygon. Okay, this is sort of a workaround here, just for the placing the text. So now, if we run the ggplot, you'll see we run the ggplot on the student origin data. Standard approach here, x-axis, y-axis, longitude, latitude. In the polygon, we're going to indicate, as we did before, to vary the color of filling each country by the number of students. But now we add the geom_text function here, and as data in the geom_text function, we're going to refer to the new dataset student origin 1, which has only one GPS coordinate per country, and this is where we want to place the text. So this is done through the mapping argument, mapping aesthetics, again, x and y, and the label is students, the number of students at each university. We add some labels here for the legend, the title, the subtitle, and the caption. Let's run it and see what it looks like. Great. So this is our Choropleth map or country map, and it shows, it varies sort of the student origin population by country and color as well.